Thank you, everyone, for joining us for this year's first History and Philosophy program guest lecture. Our guest for today is Dr. Archisman Chaudhuri, and I'm going to read his bio before he puts his slideshow on the screen, and then I will turn it over to our guest. Dr. Archisman Chaudhuri is a historian of early modern Indian Ocean. He earned his BA and his master's in the history of India at Presidency College in Kolkata in 2010. And see, oh, sorry, I've erased the institution where you got your MA. It was Nehru University.
Yeah, it's
in New
Jawaharlal
Delhi.
Nehru University. That's right.
Thank you. In 2012, he moved to the Netherlands to study at Leiden University, where he completed his PhD in 2019. His doctoral thesis is titled From Camp to Port, Mughal Warfare and the Economy of the Coromandel, 1682 to 1710. In his dissertation, he researched the relationship between warfare and economy in South Asia and the impact of the Mughal emperor's southern military campaigns on a major industrial hub of the early modern Indian Ocean. Dr. Chaudhuri worked as a postdoctoral researcher at McGill University's Indian Ocean World Center from 2019 to 2021. This is a research institute that studies human-environment relationships in the Indian Ocean world. He published an article titled The El Nino of 1685 to 1687 in Golconda and Northern Coromandel, South Asia, subtitled Drought, Famine, and the Mughal Wars. It's published in the edited volume Droughts, Floods, and the Global Climatic Anomalies of the Indian Ocean World, published by Palgram Macmillan in 2022. And he currently serves at Rutgers University as a Hallgreen Visiting Assistant Professor in History, and he's developing his first book that's based on today's topic. It is significant as a contribution to global climate history, and it sharpens our resolutions of past climate change. In terms of relevance to debates on 17th century global crises, his work reflects on the correlation between past climate change and subsistence, labor shortages and shifts, and diseases. In addition to his work as a visiting assistant professor, Dr. Chaudhuri also co-edits the Hayklett Society's international collaborative book project that's called The Norris Embassy to Mughal India, 1699 to 1702. It's going to publish a scholarly edition of the diaries of the English ambassador to the Mughal Empire, William Norris. And he is also a managing editor of the Journal of Indian Ocean World Studies that publishes research on human-environment relationships in the Indian Ocean. That's published by McGill University and listed with Johns Hopkins University Press. Thank you very much for joining us. And now you're welcome to share your slides, and I will go on mute and turn it over to you.
Thank you, Kimberly. Before I move on, how much of time do I have? How long should I speak for?
Let's say about 35 or 40 minutes to leave time for questions.
All right, great. Thank you very much.
And for our attendees, if you have questions along the way, feel free to put them in the chat. I'll be watching them there.
Okay, so shall I just pull up the slides?
Yes.
Okay. Thank you very much, Kimberly. Can all of you see my screen? And can all of you hear me? All right.
We don't see the screen yet.
You don't see the screen yet. Let me share it again. I think something went wrong. Right. Can you see my screen now?
Yes.
Perfect. Thank you very much. So I'll just start off with a bit of human story. That's what perhaps people like a bit. I'm going to talk today about past climate change in the Indian Ocean world. But I cannot move the slides for some reason. Why can't I move them? Sorry, I can't move the slides for some reason. Can you see a slide which shows a picture of the Indian Ocean world?
It's showing now.
Okay, great.
Maybe
Great.
it was just loading.
All right. Right. So the part of the world that I'm going to talk about today is the Indian Ocean world. It stretches roughly from Southern Africa in Cape to in terms of bathymetric boundaries to Java Trench, where I'm trying to hover my cursor right now. But overall, the Indian Ocean world is a much bigger space that receives most of its rainfall through the Indian Ocean monsoon. And this is an annual back and forth rhythm. The story that I'm going to tell you about goes back to the 1600s. Now, imagine climate change, past climate change, which occurred across a large part of the world. It drove peasants off their lands in South Asia, for instance, in this part, who entered bankruptcy or became enslaved laborers. Around the same time, pastoralists in Java complained of livestock dying due to a lack of pastures, while spice plantation owners in what is the island group of Moluccas complained of poor spice harvests, all of them related to a, a rainfall anomaly called the El Nino Southern Oscillation, which actually starts or begins in the Pacific Ocean. El Nino Southern Oscillation is central to my story, but that is the climatic actor. What who are the human actors in this story? The human actors in the story, unfortunately, are faceless, yet they give us a tool to sort of measure or evaluate the impact of past climate change. Right. So I'll be talking about largely three themes for the first 10 minutes or so, just to set the stage. And these are the Little Ice Age, El Nino Southern Oscillation, and Indian Ocean Dipole. If you feel these are terminologies that are difficult, that sort of scare you, don't worry. I'm going to demystify these just in a short while. Right. And some of the major themes that I will speak with regard to South Asia and island Southeast Asia include climate and subsistence, climate and diseases, and the relationship between climate, capitalism, and enslaved labor. Right. In terms of doing climate and environmental history, we follow a transdisciplinary approach. So there are largely two methods. One is paleoclimatology, which uses sources from natural processes. This could include a course of ice in glaciers, sediments from riverbeds or oceans, and so on, or tree rings. Historical climatology, uh, about which I'm going to talk today, is largely based on written sources. But both of these methods use what we call proxies. The word proxies is used to mean something that is reflective of past climate, especially for a period where direct data or instrumentation data is missing. The Little Ice Age, as we understand it, is central to ideas and arguments about glacial expansion that set in Europe and Northern America from the 1400s and continued well until the mid 19th century. The Little Ice Age, of course, had its own chronology. According to some arguments, it's actually a volcanic eruption in Indonesia in the mid 13th century that acts as the first trigger for the Little Ice Age by blocking the stratosphere with ash, which sort of disrupted the radiation balance. And the 1500s, more precisely the late 1500s till the early 1700s, formed the colder period of the Little Ice Age. And it is, in fact, this period that I'll be talking about today, mostly the period from 1600s to 1700s. This is also a period which astronomers or students of history of astronomy have called the Maunder minimum. Uh, And this is observable through a reduction in sunspots. Now, sunspots are spots in the sun which tell you about how much of solar energy is reaching the Earth. So if you have less number of sunspots, it means less solar energy and as a result, less heat. During the coldest part of the Little Ice Age, 1670 to 1710, this period formed part of what is called the Maunder minimum, and it in fact recorded less than 100 sunspots. Now, you might ask me, okay, what would a history that is so rooted in ideas of severe winters in Europe, North America, glacial expansion, what would this history mean for tropical and subtropical parts of the world? And that is where events like El Nino Southern Oscillation and Indian Ocean Dipole come in. I'm just unable to move the slide. Right. Let's take a look at this. Little Ice Age, starting off as volcanic eruptions, it puts ash in the atmosphere, which, as I said, affects the radiation balance. Now, within the sun, you have changes in solar cycles. Sunspots reduce, less solar energy, less heat reaching Earth. There is glacial expansion. And the reduction in sunspots is also connected to El Nino Southern Oscillation events. And El Nino Southern Oscillation events, I will show pictures shortly, move huge volumes of water across the Pacific. And these in turn trigger more volcanic eruptions, which sort of puts further ash in the atmosphere. And this is sort of the Little Ice Age loop that historians have talked about. Right. El Nino Southern Oscillation largely comprises three stages. One is neutral, where we are right now. Right now, the El Nino Southern Oscillation is in neutral, and there are two more stages, which is El Nino, the warm stage, and La Nina, the cool phase of it. How does this take place? El Nino Southern Oscillation usually starts off between March and May of one calendar year, and it can extend into 2 or 3 calendar years subsequently. It reverses wind patterns in the Pacific, and rainfall patterns move away from Asia and Australia to Eastern Pacific. Now, let's look at this map of the Pacific Ocean. What happens is, in a normal year, the sea surface pressure temperature in the eastern part of the Pacific, where my cursor is hovering right now, is higher than the western part. This pushes easterly winds to move along the equator towards Southeast Asia and South Asia. And that is related to rainfall processes like the Indian Ocean monsoon. And El Nino, in fact, reverses this phenomena. So this is an image that I got from the El Nino blog of North Atlantic Oscillation. And this is how El Nino looks like in a neutral year. You have trade winds moving from South American coast across the equator to Southeast Asia and South Asia rainfall. Right. In an El Nino year, this pattern is reversed. The western half of the Pacific has higher surface temperature, and this moves rainfall patterns from the west towards the east. The La Nina, which corresponds to the colder phase of the El Nino, is just the opposite. It's in fact a further strengthening or sort of reinforcement of a neutral El Nino, where the trade winds that move across the equator become stronger and you have heavy precipitation in Southeast Asia and South Asia. So historically, El Ninos are associated with rainfall deficiency in South Asia, Southeast Asia, Australia, Ethiopian highlands, and Southern Africa. And La Nina is the opposite, heavy precipitation. Along with this, changes in hydrological conditions also trigger insect and rodent vectors. And that's why these events are also associated with diseases like yellow fever, smallpox, typhus, and dengue, to name a few. Among humans and among animals, they're related to African horse sickness, anthrax, and rinderpest. The case study which I'm going to present today relates to an El Nino event in the mid-17th century. 1659, 1661 El Nino in the Indian Ocean. And most of these effects that I point out here were manifest in that event. Similar to El Nino, there is another pattern in the Indian Ocean that shapes the Indian Ocean monsoon, and this is called the Indian Ocean dipole. It starts off with a similar ocean atmospheric interaction, but it is limited to the Indian Ocean. Yet again, it has three phases: neutral, positive, and negative. Positive Indian Ocean dipole is associated with droughts in Australia and Indonesia and heavy precipitation in Eastern Africa. How does this work? So in a positive Indian Ocean dipole year, the sea surface temperature in the Eastern Indian Ocean is cooler than normal. This pushes warm waters towards the East African coast, which experiences heavy rainfall, while places in Southeast Asia and Australia experience droughts. I'm by no means a pioneering figure in researching climate history of the Indian Ocean. There have been works which deal with the scientific aspects of the story. For instance, there are works that reconstruct chronology of El Nino sudden oscillation events, pointing out that there were at least 213 events of different magnitudes from the early 16th to the late 18th century. And there are other works which try to find or offer evidence for climate change in the Indian Ocean forced by solar reduction in solar activity. For instance, there is work that focuses on C14 and beryllium-10. Both of these are produced by cosmic rays. So during the Little Ice Age, there are studies which show that these decreased in sedimentation patterns in the northeastern Arabian Sea, pointing to cooler temperatures and speaking in favor of a little ice age in the Indian Ocean. This is largely about South Asia. For Southeast Asia, there are records from tree rings. So longer, wider, thicker tree rings pointing to heavier rainfall, while shorter, thinner tree rings pointing to dry years. And this is an argument a Dutch scholar made in the last century, that Java in Southeast Asia experienced drier years between 1640s and 1670s. There are also scholars who have used corals to study past climate change, and they point out that serious Indian Ocean dipole events occurred twice in the past. In the 17th century, in 1660 and 1665. I'm going to take a look at the 1660 event. And if any of you are interested, you can look at the Smithsonian Institution's Global Volcanism Program, which offers a list of the volcanic eruptions. This is where my work really takes off. I draw upon argument of a climate historian called Richard Grove, who made this argument that 17th century climate crises were common to South Asia and Southeast Asia, at least the major years like 1616 to 20, 1629, 32, 1659, 61, and 1685, 87. On a global scale, this had parallels with Mexico, which experienced droughts and floods almost around the same time as major events in the Indian Ocean, while severe European winters preceded El Nino events in South Asia. If we sort of plot this on a global scale, it looks like this. For instance, you have 1618-21, a major El Nino event, and La Nina following it in South Asia. This is associated, or the Mexican parallel is droughts. And Europe experiences colder winters before this event. Similarly, again, in 1684-85, which was a major El Nino event in South Asia, Europe experiences a harsh winter. And this pattern, sort of continued on other occasions too, in the 17th and early 18th century. For historians or for a wider audience who do not deal with climate history is sort of a niche aspect, and I can understand it can be a bit boring or dry at some times. How do we talk about this to a wider audience? It is through the idea of 17th century global crisis, which was popularized by Jeffrey Parker in various works since the 1970s, and there are different aspects to this. For instance, John F. Richards argues there is little evidence of crisis before the late 17th century in South Asia. In Southeast Asia, there is evidence of serious crisis in the mid 17th century, while another historian, Peter Baumgart, points out that the worst years were not common to South Asia and Southeast Asia. Especially the last argument needs revision, and that is something which I'm going to try and do in the next couple of minutes. In terms of South Asia, although there is not a major crisis until the late 17th century, there are definitely short-term crises which have serious impact. And what's a sort of historiographical intervention that I'm trying to make? I make 4 points. One, climatic and environmental angles are less explored for 17th century crisis in South Asia and Southeast Asia. And in order to do this, I look at comparative climate histories of coeval climate events. What does this do? This generates more granular data on climatic anomalies like El Nino sudden oscillation, and in turn, this also improves the scientific paleoclimatology resolutions of past climate. How do I do this? As I pointed out, I take off from the work of Gerges and Fowler, who construct an El Nino chronology for much of the early modern period that I'm looking at, and Richard Grove's coeval 17th century climate crisis thesis. But how do I study all of this? I study all of this using the archives of the Dutch East India Company, who were a major mercantile and colonial power in the early modern Indian Ocean. And their correspondence proffers evidence on seasonal rainfall patterns for El Nino sudden oscillation, Indian Ocean dipole years, and even normal years. In short, it is possible to reconstruct seasonal impressions of rainfall in the Indian Ocean using the VOC archives. So who are or what was the VOC? The VOC was a major maritime power. They were restricted to the role of traders largely in South Asia, while in island Southeast Asia, they were an aggressive colonizer. And what did they trade in? From South Asia, they traded in textiles, black pepper, and cinnamon, mainly from Ceylon. In Southeast Asia, the main components of their trade included spices, pepper, cloves, mace, nutmeg, and as you will find out shortly, some of the information on rainfall failures or excessive rainfall comes through reports on production of spices and spice plantations. In short, in writing about their trade, in commenting on the living conditions, the VOC offer observations on droughts, floods, agriculture, spices, volcanoes, and even earthquakes. That is why they form a major source base that we could tap in order to research Indian Ocean climate histories. And what are the regions I'm going to talk about? One of the main regions that features in my work is the Coromandel Coast, where my cursor is hovering right now. Can you all see the map? Okay. So this was where the Dutch were based since the early 1600s, and their correspondence makes it possible to reconstruct seasonal rainfall patterns for El Nino sudden oscillation years in the Coromandel Coast. Region 2, or right. Part 2 of looking at Coromandel Coast is it had 2 monsoons, a minor one in June to August and a major one during October to December, which helped in producing its primary subsistence crop, rice. It was also, as I pointed out, a major textile manufacturing hub of the early modern Indian Ocean, and it was an inland market for spices. Southeast Asia, Java. The parts of Java that will feature in today's talk are Batavia, which was the Indian Ocean capital of the Dutch East India Company, and the Sultanate of Mataram, and the island group of Malukus, or also known as Moluccas, primarily Ambon and Banda. Here is another map of Ambon and Banda, and they were the major producers of spices that the Dutch traded in, cloves, nutmeg, and mace. In terms of climate picture, Java experienced a wet season from November to March and a slightly drier season from April to October. And it was just like Coromandel, a place of intensive rice cultivation. The Dutch were a limited political power in Java since the early 1600s. However, in the Moluccas, which produced the spices like cloves, mace, and nutmeg, the Dutch were intent on colonizing right from the early 1600s. So they colonized the Banda Islands beginning in the early 1600s. And in Ambon, about which today I will talk, experienced limited Dutch expansion till the 1650s. The difference of this region with the other two, Coromandel and Java, is these places were not major producers of subsistence crops. In fact, they relied on trade in rice. Moreover, these were endemic disease zones. Smallpox used to break out every 7 or 8 years, and it was a major cause of depopulation. This is the case study I'm going to present to you today, primarily because I have been writing an article on this, which has been under peer review for the last 6 months. It comprised two major climatic anomalies: El Nino sudden oscillation during 1659 to 1661 and a positive Indian Ocean dipole anomaly in 1660. I will focus on reports two uh, for two seasons. One is the boreal summer or the northern hemisphere summer during June to August, and the other is the southern hemisphere or the austral summer from December to February. And I use a 3-point index to determine the amount of precipitation: excessive, deficient, and regular. But how do I arrive at this data? As I said, a lot of the data that we get when reading written sources on past climate comes through indirectly. For South Asia and Southeast Asia, a lot of this comes through reports on harvests of rice and spice because these were closely tied to rainfall patterns, uh, livestock mortality, and also reports from ports. For instance, how ships would be affected during storms and so on. Let's take a look at the broad patterns of what unfolds in the Indian Ocean region in South Asia and island Southeast Asia. 1658, the Coromandel Coast experiences a deficient monsoon, and then it moves through two seasons of excessive rainfall before rainfall returns to regular in 1661. Java, on the other hand, does not experience any excessive rainfall during this anomaly. It largely experiences deficient rainfall for two seasons, which were preceded and followed by regular rainfall. Moluccas, sort of closely mirroring the Coromandel Coast pattern, they report two seasons of excessive rainfall, uh, sorry, 3 seasons of excessive rainfall and 1 season of deficient rainfall. How do I arrive at this data? Here is the sort of historical climatology I try to do. 1658 season, boreal summer, June to August, Ambon, Southeast Asia, it produces cloves. The Dutch write that heavy rains have destroyed the budding clove plantings that we were so hoping on. So that is the information I use to determine this is a period of excessive rainfall. On the other hand, almost same year, Coromandel Coast in South Asia reports poor rainfall. It's it's a season of bad rice harvests and grain prices increase. This is how I translate this as deficient. Java, on the other hand, reports good rice harvests, ample stocks, nothing to worry about. Things change drastically for the next 2 years. 1659, boreal summer, Ambon, heavy monsoon continues. Coromandel Coast, in sharp contrast to the drought that they experienced in 1658, starts reporting heavy rains, largely in the northern parts. However, in its southern parts, it still continues to report deficient rainfall, which, along with warfare, increases prices of rice. So it is a season of both excessive and deficient rainfall. Java, on the other hand, which had nothing to worry about in 1658, suddenly starts reporting that cattle are dying because of lack of pastures, which are drying up, and rulers are constructing granaries because they fear a shortage of grains due to rainfall failure. And this is the sort of report that continues for Java for much of 1660 until uh, January 1661, when the Dutch report rains return to Java. So Java clearly moves from 2 seasons of deficient rainfall to regular rainfall. Similarly, Coromandel Coast, after 3 seasons of deficient and excessive rainfall, moves to regular rainfall from the mid 1660s. On the other hand, Ambon, the spice producing parts, they still keep reporting weather anomalies, largely in terms of dry weather. It's only in 1661 that rains return to Ambon, but yet again, it's an excessive rainfall, not regular. Interestingly, this time the Dutch write about heavy rainfall not in the context of spice plantations, but simply because pastors could not visit churches because the monsoon rains washed away the roads. On the other hand, Java and Coromandel report regular rainfall and good rice harvests. So overall, it was a period of 3 seasons which experienced rainfall anomalies. If we sort of try and draw a few insights, how does this look like on an El Nino subnoxylation scale? Coromandel starts off with drought, then moves to heavy rainfall. So it's clearly the wetter conditions of El Nino subnoxylation or La Nina, which are stronger. Java, no heavy rainfall. It moves from drought to regular rainfall. So it sort of mirrors the El Nino La Nina pattern, deficient rainfall, then excessive or regular rainfall. Ambon, on the other hand, yet again, La Nina conditions are stronger because it moves from heavy rainfall through drought to yet again heavy rainfall. That is comparison, that is historical climatology case study 1. I'm going to try and make a short comparison with another event in the same regions from the 1680s. Coromandel Coast this time experiences 2 seasons of deficient rainfall followed by an excessive rainfall. So from 1685-86 deficient to 1687 excessive. And then Java, closely mirroring the 1659 pattern, it just experiences 2 seasons of deficient rainfall, while the rest of the graph looks like regular rainfall. Moluccas, yet again, it's excessive rainfall that moves through deficient rainfall to yet again excessive. So clearly, if we compare this, in the 1680s on the Coromandel Coast, it's the El Nino pattern which is stronger. Moluccas, yet again, just similar to 1659, La Nina conditions are stronger. Java, for some reason, and unfortunately, I'm not a climate scientist. I do not really have an explanation in terms of the atmospheric patterns to this. Uh, it just experiences 2 seasons of drought. It does not report excessive rainfall. What does this mean for historical climatology? Southeast Asia, primarily Java, experiences rainfall deficiency at least one monsoon season after South Asia. 1658 Coromandel, 1659 Java. It's a similar pattern when it comes to heavy or regular precipitation. 1659-60 Coromandel, 1661 Java. In general, Coromandel and Moluccas reported at least 3 or more seasons of rainfall anomalies, unlike Java, which just experiences 2 consecutive seasons of drought. Now, if I try to translate these climate data into how it impacted climate-human environment relationships on the ground, what do I do? As I pointed out, I will look at 3 themes: climate and subsistence, climate and disease, climate and labor. First theme, climate and subsistence. Famine is reported quite early on the Coromandel Coast in South Asia, and this happens through a combination of bad rice harvests and local warfare when armies consume food resources. The Dutch report starvation deaths. Java never experiences a serious threat of famine. It largely relies on rice stocks from the previous year, 1658, and trade in foodstuffs. Um, the daily register, which was kept in the Batavia Castle of the Dutch East India Company in Batavia, reported regular shipments of foodstuffs like rice, meat, dried fish that kept on arriving in Java through 1659 and 1660. This meant the region had a decent food security for humans. However, livestock perishes. If I move further towards Eastern Island, Southeast Asia, famine was a serious threat. What do we find out? The VOC in Ambon, they rationed rice over 1660 and 61 for their soldiers they reduced the quantity available for soldiers from 40 to 20 pounds per month. And they also relied on an alternative staple food called sago, which is the edible palm starch, and this was used to bake bread. Although this helped them limit the incidence of famine, this also had serious consequences for nutrition, as we will find out now. In terms of climate and diseases, it's difficult to relate the 1659-61 event in Coromandel to any major disease outbreaks, which is unlike the 1685 case. Deaths are largely reported due to famine and not serious diseases. Both in Java and Ambon, there are reports of smallpox outbreaks, which both precede the anomaly and then follow it. So it's really difficult to sort of construct a disease pattern for these two regions for the 1659 event. Both the disease outbreaks in Java and Ambon were possibly linked to hydraulic conditions. What did this mean for climate and labor? On the Coromandel coast, famished labor entered into slavery via the networks of the Dutch East India Company. And despite a substantial depletion of labor, survivors could work rice harvests from 1661, and the Dutch do not report any harvest failures in the region because of a lack of labor. Similarly, they do not report lack of labor in Java during 1661 and 62 because able-bodied labor clearly survives the famine threat, and it's able to work the fields when rainfall returns to normal during 1661. This had serious implications for food security. In 1662, if you remember what I said in terms of the vector impact of El Nino events, they trigger insect and rodent vectors. In 1662, rice fields in Java were infested by rats. Despite this, Java does not report a famine for the next couple of years because they were able to salvage most of the rice harvest. On the other hand, Moluccas, a lot of the labor in the Dutch spice gardens is killed due to smallpox and fevers. And this is perhaps where we need to talk about the proportion of nutrients in rice versus proportion of nutrients in sago. And I clearly do not have quantitative data here, but the Dutch do report that the labor is so weakened by fever and smallpox outbreaks, they are unable to work the fields or even work in the spice plantations. This was the entry point for human impact of the climatic anomaly in 1659 and 61 to appear in South Asia and Southeast Asia. Famines in South Asia and Southeast Asia offer a differential impact story. Slavery in the Dutch networks was a result of serious climatic anomalies like El Niño subnoxulation and Indian Ocean dipole. On multiple occasions during the 1600s and 1700s, enslaved labor migrated via the VOC networks from South Asia to Southeast Asia. 1618, 20, 1659, 74, 75, 85, 87, and yet again in the 1700s. I argue this is the human impact of climatic anomalies. And this is the story that I like to tell. I do not have stories about a certain family that I could use to make the human impact more sharp or more prominent. But these were faceless humans displaced due to climate change in combination with other factors who provided cheap labor. And the Dutch sort of capitalized on this right from the early 1600s. Let's take a look at a few examples from the VOC archives. 1622, the Dutch clearly make this argument that We have many slaves arriving from South Asia, and we should send as many ships as we can to South Asian regions like Ceylon, Coromandel, and Bengal to procure slaves in order to work our colonies. And in the early 1620s, it is possible to trace the trajectory of these slaves. Few of them, or more precisely 200, moved from Batavia. So they originate in Coromandel Coast, they move to Batavia, and from Batavia they're sent to work the spice gardens in Ambon and Moluccas. This pattern repeats in 1659. For instance, let's take a look at these two concrete examples. Late 1660, the ship Ulysses arrived in Batavia from Pulicat with 295 slaves. Coromandel has delivered a great number of slaves, and there are a few more that we still need to ship from there. Around the same time, they're writing about Ambon, which has experienced shortage of labor, as I just pointed out. And the Dutch plan to address this labor shortage by supplying slaves from Coromandel Coast that have arrived in Batavia. All of this happening within a phase of a year and a half. So, how do we understand global climate histories of the 17th century? If anything, what I try to point out today, global climate crisis in the 17th century had multi-scalar impact. And events like El Nino subnoxylation, which originate as differences or anomalies in the Pacific, affect rainfall patterns and agriculture across large part of the world. And in using written sources to research impact of past climate change, we are in fact improving paleoclimatology models of past climate. Not only that, if I try and sort of translate this into the 17th century global crisis debate, how do I, what sort of a position do I take? These are essentially short-term climate crises, yet they have serious impact. And this impact is writ large over South Asia and Southeast Asia, largely through histories of enslavement, histories of mortality, and histories of migration. As we saw in Southeast Asia, social adaptation could shape intensities of famines. In integrating these sort of differential impact from South Asia and island Southeast Asia, I'm trying to argue that global histories of 17th century climate and socioeconomic crisis have a lot more to offer. I think I will stop there.
Thank you very much. You gave us lots
Like,
to think about,
did I
and
exceed
yeah,
the time?
no, we are right
All
on
right.
schedule. We have 16 minutes for questions, and yeah, I know I'm still thinking very much about how this relates to my classes, but first I will turn it over to our attendees. If you have a question or comment, you can raise your virtual hand. Thank you, Michael, or you can also type it in the chat and I will read it for you. Michael, you're welcome to go first.
Thank you. Thank you. This is a really, really fascinating sort of peek at your research. I'd like to ask you to expand a little bit about your sort of concluding remarks about sort of changing this larger debate. I'm trained as a Europeanist, so the kind of the closest thing that I'm familiar with is a kind of Brodelian analysis of the Mediterranean and how climate over the longue durée does this and that and that. So I'm less familiar with sort of the sort of Pacific, not Pacific, the Indian Ocean climate, and I'm wondering really sort of how this really does change that debate about a kind of a global crisis, right? I'm familiar with the European part of it, especially the Little Ice Age, but I'm having a little bit trouble seeing the bigger picture here, right? The kind of specific things you talked about, I found very convincing, but I am having a little bit of trouble understanding your larger contribution here, and I'm sure it's my fault.
Um, well, thank you. Probably I should clarify. So it does not change the global 17th century crisis debate. what I'm trying to do here is add more data to it, bring in regions that are sort of not so well represented in it. So whenever we talk about Little Ice Age, the idea itself starts off with colder climates, and that is my entry point. What does this mean for regions that do not necessarily have, you know, winters where you experience a lot of frost, or mountains and so on? Clearly, there is a tool or a means to enter that debate through the idea of El Nino subnoxylation, because it influences subsistence and also trade to a great extent. In terms of specific connections between the regions I talked about and the broader resonances of this story, I think what it does in terms of South Asia is, in South Asia, the standard argument is John F. Richards, who points out, because the Mughal Empire provides so much of social stability and political security, South Asia is, in fact, at this point of time, one of the richest parts of the world. And you only have a crisis towards the late 17th century, when there is a warfare for expansion in the southern part, and there is a budgetary deficit that the imperial nobility are complaining about. But my point is, if we simply disregard all that argument, I'm not in terms of disregarding, okay, that argument is valid, it stands its ground, but there are these episodes of serious short-term crisis which clearly displaces some of the more disadvantaged sections of society, who often do not have an alternate to food security. And the answer is, they enter into slavery. And the Dutch, I should point out, are just one actor. There are also other private actors in the story. The English East India Company, which operates in South Asia at this point, they're not as big as the Dutch in terms of commerce, but they are still powerful enough to participate in Indian Ocean slavery. And so what these short-term events represent are essentially short-lived moments of crisis. For instance, if I compare this with the 2 years of COVID, it's just 2 years, 2020 and 2021, yet we are still living with it. But within that short window, the impact was so serious that it definitely merits some more historiographical attention. That is my argument for South Asia. Now, for Southeast Asia, there is clearly a crisis that appears in the mid 17th century. That part of the argument by Anthony Reid is good enough on its own. The climatic aspect of that story is not so clear if we read Anthony Reid's account of the crisis. Clearly, the El Nino chronology is not very prominent in his work. The other historian, Peter Boomgaard, who tried to do this, he was also a Dutch historian, argues that the main years of crisis are not common to South Asia and Southeast Asia. Instead, and what I try to point out is, these years are common to South Asia and Southeast Asia, drawing upon Richard Grove, and clearly there are connections that emerge between these two regions. So perhaps there is a need for a fresh look at how these short-term climatic events and the crisis they caused in South Asia and Southeast Asia, we need to take a fresh look at those events. So I'm not denying the 17th century crisis story, not at all. My point is, I'm using the climate story to enter that debate, because I need to make this history more accessible to a wider audience, in terms of historiographical contribution. And it is still something which I'm working on for the book, and thanks for that comment.
Thank you. That helped tremendously.
Pam, you can go ahead.
Okay, thanks. I really appreciate the transdisciplinary approach that you're taking in this material, and also some of the challenges, of course, and complexities that come up because of that. But I'm curious if maybe you could even expand a little bit more and create more of a human face, as you were talking about, to your story. If you were to include more travelogue material or works from creative literature, from novels and poetry of the time. And I was just curious if you were familiar with anything that might apply to that.
There are a few travelogues which, well, thank you for the question. There are a few travelogues which talk about the 17th century climatic events, but they're not so useful in terms of reconstructing the climate data. And that is what I've been working on until now. So in answer to your question, yes, that is what I do want to do, because a lot of the story, when it relies so much on climate data, can read a bit dry. But there are a few examples. For instance, the 1685 event, about which I have written earlier, there is a curious history of Coromandel written in Dutch, and this was written by a Dutch official who was posted in this region called Daniel Havard. And he talks about how the diseases that followed El Nino and La Nina in Coromandel affected Dutch families who were living in a port called Masulipatam. It was, of course, one of the major ports in Bay of Bengal in the 17th century. And he talks about the family of the Dutch director. So he says most members of that family died due to smallpox and fevers during the 1685 event. It's only the father and the daughter who survive. And then they decide to migrate to Batavia. And in Batavia, what happens? The daughter dies from smallpox. And there is a possibility that smallpox, and this is something I still need to work on, smallpox might have spread in the Indian Ocean through enslavement networks, because many of the slaves that the Dutch buy and move across from South Asia to either Cape Town in the 18th century or Batavia and Moluccas in the 17th century, they suffered from smallpox. And the Dutch make this argument repeatedly that we should just stop moving these people, because they are clearly not recovered and they're just going to infect more people on board. So that is perhaps one human angle which I do want to explore a bit more. And in terms of poetry, I really haven't thought about that. So thanks a lot for that insight.
Thanks so much.
And our next questions are from Nilla and then from John.
Thank you for the presentation, Professor. And I apologize in advance for asking slightly outside of the time frame, but a student in a global Asia class from last year had written a paper about the Kangani labor system that I think took place like in the centuries following. And I was curious if you think there's a possibility that El Nino Southern Oscillation or similar climatic events might have had an effect on that as well.
Okay, so this is something I have worked on a bit, but I never really seriously wrote on it. In general, if you read histories of slavery in the Indian Ocean world, especially centered on South Asia, you would notice that South Asia always produces a certain number of slaves during years of famines or climatic stress. And the pattern clearly does not start in the 1600s. The Portuguese were aware of it before the Dutch in the 16th century. And this pattern sort of continues in the 18th century, although the 18th century El Niños were not as severe as the 17th century ones, but people were moving to new colonial centers. The 17th century story I try to talk about, slaves are mostly moving to either Batavia or the Spice Islands of Moluccas. 18th century, they're also moving to the gold mines in Sumatra, roughly from the same region in South Asia. It might be possible, but I really do not have an answer to that. I'm sorry right now, but it's something that we really need to dig into. And there is also, if you're interested, there are also histories that look at movement of slaves from South Asia to Southern Africa, but that sort of takes off only from the 1730s and so on. Yeah, but thanks for that question. That sort of stumps me a bit, but I'm going to look into it.
Thank you.
And John, you can go ahead.
Thank you, Dr. Hill. And Professor, thank you so much for taking time out of your day to give this informative presentation to us. To be honest with you, the 17th century global crisis and the climatic events in different parts of the world is certainly a new area for me, but I love learning. So thank you for this. I certainly learned a lot about how climate plays a role in everyday life. I was actually curious, though, if you'd be willing to elaborate a bit more on how debates about the 17th century climatic events how would you say, how can they be useful for us in shaping our understanding of human rights? And then perhaps in your research, you might even consider including material about refugees, for example, who are who are migrating from one part of the world to the other, given that, there's oftentimes we talk about refugees, we talk about people who escape from war and persecution, right? But there are also those who leave their homes because of a climate crisis. So that's just something to consider, maybe including stories of refugees who are immigrating to different parts of the world due to what's happening in their homes.
Well, thank you. There were two parts to this answer. I will start off with the easier one first. In the article, which I published in 22, I actually used the term that these people are sort of climate refugees of present day because they're displaced by climate stress in combination with other factors. Well, whether they are really refugees in the modern sense is something we should be careful about, because you could argue that they pass off from one state, which is there were different kingdoms in southern India that they originate from, but they're moving to sort of a mercantile colonial state in Southeast Asia, which then sort of passes them on to individual owners of spice plantations. So clearly there is a state boundary involved. In terms of human rights, yes, and that is why I call climate-induced slavery the human impact of climatic anomalies. Otherwise, it's so difficult to actually pin a face or put a face on these people. I really haven't thought about the idea of human rights in this aspect, but there are other scholars who work on slavery, particularly for Northern Europe and Central European countries like Germany and Sweden. And they do use the idea of human rights in a very limited context. So for instance, in the 1600s, there are attacks in northern Mediterranean, or sort of northern coast of Africa across the Mediterranean by Barbary corsairs who kidnap and abduct people from ships, and then they are enslaved. I think there are reports on how town councils and village people in Sweden, Germany, and the Netherlands in the 1600s, early 1700s are making petitions to their states. And I cannot recall the names of the scholars, but I heard this at the AHA annual meeting earlier last year in a panel on slavery. And the idea is that clearly these are people from our countries and they have a human right. So we need to pay the whatever ransom amount is, and we need to bring these people back. Do remember, at the same time, that this involves French as well. And within a century, you have the French Revolution, which talks about human rights. And there is so much of idea about emancipation. And that does not apply to slaves in the French enclaves, either in the Indian Ocean or elsewhere in the Atlantic. And it's the same story for Dutch slavery in the Atlantic or in the Indian Ocean. So even if I use the idea of human rights for these people, I have to be careful that I'm sort of entering a very murky field of debate of how we understand how we understand or define what is a human right. Does that answer your question? I'm not so sure, but probably I sort of gave you some food for thought.
Yes, sir. That was very helpful. Thank you for sharing those insights.
And thank all of you for your questions and comments. We had one more comment from from Dr. Pam Gosson recommending Indian Astronomical Observatory data as a possibly helpful source. And yes, and with that, we are at time. So thank you to our speaker, Dr. Archisman Chaudhuri. Let's do our virtual hand claps.
Thank you very much, Kimberly, and thank you so much, Rosemary, for organizing this. It was wonderful. It was wonderful to talk to students after a few months away from teaching, and it was clearly the highlight of my spring this year. And yeah, it was great.
We're very glad to have you.
I hope I at least tried to do some justice to a difficult topic within half an hour.
Thank you.
We get so little exposure to your topic and to your approach. So yes, this is very valuable for us. Thank you to all of you for joining us for our lecture series, and we will keep in touch when we have another speaker. We hope you have a great afternoon. And Archisman, if you can stick around for just a few more minutes, please.
Professor, if I hadn't gone to UT Dallas, I would have gone to Rutgers. So thank you.
Well, we didn't miss each other.
We've got an extra thank you from Dr. Ravi Prakash in the chat. Yeah, that was wonderful. Thank you so much.
Thank you so much. It was so great, and it got me thinking about my own teaching and my own assignment that's a primary source analysis